Welcome, I'm Joshua de Lisle, the designer maker. Today we're testing the new Horl2 professional sharpening system. More on them in a little bit. But first I'm going to attempt to forge a new style of blade. So let's get down to it.
I'm forging an experimental ironclad knife. These style blades are popular in traditional Japanese culinary, but examples of this style of forging can be found in Celtic and Viking archaeology. To fuel this experiment I'm using traditional charcoal, which was used for thousands of years for blacksmiths and only stopped because coal production was far cheaper. I'll be showing you in a future video how I create sustainably made charcoal using coppice wood, because as you can imagine, coal and coke is at a record high and charcoal production is now proving to be far cheaper. So this method of ironclad blade is still very popular in Scandinavia. So it's originally thought that this style of forging was to make a saving on good quality steel. Now the idea is, especially in the time of the Vikings, that the high carbon steel, the good steel, was so difficult and expensive to produce that they used to only use tiny amounts. And then the rest of the bulk of the sword, the knife or the axe was made with poorer quality or low carbon iron. Now if you didn't know already, but low carbon and pure irons are not affected by heat treatment, if not very little. Understanding this will give the blade some excellent properties, which we'll go into details when we talk about the heat treatment. And by the way, this is the DIY power hammer that we built in a previous episode, so if you're interested, do check it out in the description. Now it would be interesting to hear your thoughts and opinions on this in the comments section, but what do you think's better, a power hammer or a hydraulic press? Now my opinion is that a combination of both would be the best option to have. When it comes to bladesmithing, a hydraulic press has proven itself. You can get a nice flat and even forge weld and you can move a lot of metal fast. Now on the other hand, the power hammer is able to impart energy back into the steel using its impact force. On the opposite side, the hydraulic press is slower moving and therefore it's actually leaching energy out of the steel as it's touching the surface. This means the power hammer has the advantage, especially when it comes to forging thinner sections. And so I would also argue that the power hammer is more efficient when it comes to the conservation of energy. That being said, the power of hydraulics is incredible and I would certainly love to have a machine like that in the workshop. Coming back to the idea of ironclad blade forging, there is another benefit which comes into the making part itself. Now you've been watching me use a flux called borax, which is stopping the steel from oxidization. Without flux, the high carbon steel is likely to burn away. But the other property of a low carbon steel or pure iron is that the melting temperature is far higher. On the other end of the spectrum you have cast iron, which has incredibly high carbon content for the very reason that it has a lower melting point and therefore is easier to cast. So traditionally they didn't have fluxes available, or if they did they would have used something like silica sand. So another idea is that if you actually entomb the high carbon steel in a low carbon or pure iron, you'll actually protect it from the oxygen in the air when it gets to critical temperature. I actually achieved this by forge welding a piece of high carbon into a wrought iron axe, and it came together beautifully without the need of flux at all. However, using that method does come with some material wastage, as you need to grind back all of that material to get back to the good high carbon steel in the core. Now ironically, I did have to cut quite a lot of material off this blade because I simply added too much. So theoretically I could have used the encasement method and that would have worked out just fine, and I wouldn't have had to have relied on any flux. However, flux does have the benefit of being able to clean the material, takes that scale off really nicely. So I created this tool with a few more bits of spring steel in order to both flatten the surfaces but also really pinch that edge. What I really want is that high carbon and mild steel edge to go to an absolute fine point. This is also going to make it a lot less work when it comes to the final grind. And if I'm honest, that's the one thing that I don't like about bladesmithing, is I like forging. I don't like to spend the time grinding. There are some bladesmiths who don't forge at all, they simply cut the material out and grind the rest. In fact, you can even buy in pre-made Damascus steel for that very reason. Prior to grinding, I'm actually going to anneal the steel, so I'm just heating it up and then submerging it into the ash and coals here. That way I'm eliminating all the stresses and tension from the forging process, and I'm able to start afresh with the heat treatment. Now, sand and ash has excellent heat retention properties. In fact, they use it for industrial thermal batteries, and so even after several hours this piece of steel was still very warm. So the offcuts from the cutting here I actually used to do a test heat treatment just to make sure I got my methods correct, and they came out pretty well. Now, I do actually own a belt sander, a very good one, but it's currently in storage. But when I looked at the prices of how much the belts were, I was quite taken back. So because this is just an experiment, I decided to just do it all by hand, and it turned out just fine. However, it wasn't ground perfectly flat, and I did leave a lot of imperfections, which I kind of regret. It's a lesson to make sure each stage is done properly, and therefore you don't have to go back on yourself later on. So now it's time for the heat treatment, and we'll talk about those beneficial properties. So I'm using the induction forge for this part simply because of its convenience, as the coals had already gone out. I made myself jump here as I shorted the coils. I then discovered that it was actually more beneficial to put the blade on the edge of the coils like this, and it was really good to see the colours coming through, and I could get an accurate heat treatment. So the benefits that are happening here is only the core of the steel is getting heat treated, and that cladding is actually remaining quite malleable. Theoretically, this means I can be quite brutal when it comes to the heat treatment and get that steel extra hard, and that laminate layer is actually improving its properties, stopping it from becoming as brittle as it would be normally. I've also quenched in water, which is what they would have used traditionally. But there's also a risk of cracking and bending when you do that. But having that soft, malleable layer, I believe, is preventing that from happening. So I'm cleaning the surface up now for the tempering. And as you can see, I'm getting a very slight waving of that blade edge. I think it's more to do with my grinding than it is the heat treatment. Anyway, here I'm heating up a piece of 30mm solid section. And what I'll do is I'll use the radial heat from this to then temper the steel. So moving on, what I'm looking for is a straw-like colour, like a very yellowy colour on the blade edge. You could really see clearly at this point what was mild steel and what was a high carbon underneath. The patination was just beautiful, and I was really tempted to try and save it. But it is just an oxide layer, and it would never have stayed on there very long. Now this part I thought was a very interesting experiment. I'm using a popular drink. I won't mention the brand name. Maybe we'll refer to it as child teeth rotter, or even plastic ocean island maker. Either way, I don't buy this stuff for drinking, and I don't really support the brand, but it makes for very good knife etching. So I basically left it in there for about 4 or 5 hours under a very low heat. You can see I had a little alcohol burner underneath my little pot there. So I thought that I'd have to buy some hydrochloric acid, like what I would use to do the weld test. But it turns out that this diabetes in a bottle has just enough acid to do it itself. So this may be my favourite part of the knife, where I show you how I actually designed the handle. And I actually used a piece of plasticine, and I just kind of moulded it in the hand around that handle until it felt right and I could use it comfortably in different positions. I then transferred it to be an actual design, which I then transferred onto a block of wood. Firstly though, I need to make a bolster, and I'm just going to use this piece of scrap mild steel. And to do it, I'm just simply drilling the holes first and then filing them back to make the little slot. Now a set of needle files would have been really helpful, but instead I just modified this chainsaw file, which worked perfectly. I quickly dressed it with the grinder, and then afterwards I actually did heat it up just to put that oxidization back onto it so it looked in keeping with the rest of the blade. So you can see I've also dressed back the tang, and that way the bolster can seat against it really nicely, closing up any gaps. Now the wood I'm using is an offcut from another project, and it's lime wood, or otherwise known as linden, which is apparently excellent for carving with. It's often used for things like spoon carving in bowls, so I thought for culinary it will be quite good. Having a bolster also means that I didn't need to be as precise when it comes to the slot for the tang. Now, I'm not sponsored at all by JB Weld, but they are definitely one of my favourite epoxy resins. They just work so well and is very, very strong. I'll try and leave a link to all of these special things that I use in the description. Now, if you are a professional knife maker, not like me, it would be handy to know what kind of products you guys use for the fitment of handles. So I encourage anyone who either disagrees with what I do or has other opinions or has experimented with other things and found that they work. Let the comment section be a place where everyone can kind of collaborate, join together and learn new things. As I say, this is all experimentation, and I'm not doing this because I know everything. I'm doing it because I'm trying to learn stuff. And often that's just by me looking at the comment section and getting some real feedback from people who clearly know what they're doing. So to make light work of carving this handle, I got out my chainsaw disc, which seemed to work quite well, although it can be quite aggressive and take far too much off if you're not careful enough. Now, it would definitely have made good viewing if I'd have carved all of this out using, draw knives and carving knives and things like that, and making beautiful chips. However, sometimes for efficiency's sake, you just need to get things done, and therefore that's when the power tools come out, I'm afraid. Now, if I decided to make a production of these, I would consider CNC routing them, or even making my own copy lathe of some sort. Which, thinking about it, making a copy lathe isn't a bad idea. I think that would be a very interesting project. If you don't know what a copy lathe is, I recommend looking at Liam Hoffman's axe making production. He's got a beautiful example of what one can do. So on stainless steel, laser etching comes out beautifully, and I didn't quite get the effect I was looking for on carbon steel. Instead, it gave me this shiny negative on the etched steel, which kind of works. I'm using linseed oil for the wood, but I use mineral oil for the blade. So whilst the laser was out, I decided to make something called a saya, which is basically a wooden sheath, very popular again in Japanese culture. So to design this, I basically took a photo of the blade and drew around it in my CAD software package. And I used a critical measurement as a point of reference, and the blade came out fitting perfectly. Now, if you're interested, I'm certainly not sponsored, and I don't really fully recommend them, but I use SketchUp Pro is my CAD software of choice. Can't really comment whether SketchUp is good or bad, because it's all I've ever used. So because I intend to use this knife for outdoor cooking, I thought it would be absolutely appropriate to use some paracord to just have that bushcrafty feel about it. It was really good fun relearning all the ropes, but I think I'd use some different knots in future just to make it a bit more of a cleaner design. So I love the way that this came out in the end. The saya came out beautifully. Now I did think about putting a little etch design using the laser. That's definitely something that we could do. But I actually prefer this lovely clean look. It's very kind of Japanese style. So when the saya is opened, it's a perfect fit for the knife. It's not going to fall out. Just a little kind of push there and it comes out beautifully. This handle is super comfortable, and the idea of this ridge here is that when you grip it like this for chopping, slicing, that just neatly tucks into your palm. The finger grip around here feels very nice, and even if I use it like a hatchet, it's still a really nice comfortable grip. But the etching worked out beautifully. You can see where the mild steel comes right to the edge of the high carbon. That's going to give it lots and lots of strength. Let's take a close look at the Horl sharpening system. Horl 1993 was started by a father and son 30 years ago. They've specialised in making excellent quality sharpening stones and came up with this design. As you can see, the sharpening stone itself has a fine and a coarse side, and it's on bearings. You also get given this block which has high strength magnets onto it, and if I put it to the correct 15-degree side, it holds the knife in place like that. Now the idea is that we're going to go and roll backwards and forwards very easily, very conveniently. Before we do this, I'm just going to set up with this lovely mat that they've given me. That way I can keep everything clean, and any of the filings I can gather onto the mat and chuck away. Horl also gave me these premium sharpening stones as well. So this is a 3000 grit stone,
This is a 6000 grit stone and a leather strop for the final finish. So these are made from quality oak from the Black Forest right in the heart of Germany, which is where these quality products are made. I'm going to begin by using the 15-degree side. There's also an option for 20 degrees also. So to use the sharpening system, first place your block on a surface, then put your blade against the magnet like that and it will stick to it. Make sure it's pressed and goes all the way down to the bottom. And then in this orientation, I like to put my thumb just on the handle, just to keep everything nice and secure whilst I'm sharpening it. And to do the opposite side, simply place the blade in this direction. And then what I'll do is extend my hand to put it onto the handle like so, always keeping all my fingers away from the blade edge, like that. Now, the sharpening stone itself has a coarse diamond grit this side, and a honing grit this side. So to establish the edge, I'm going to first use the diamond grit. And then it's literally just engaging it with the blade, doing a forwards and back motion, going all the way to the very edge. And what I'm trying to do is do equal amount on both sides, or a timed amount. It's going to take me a while to establish the edge, just because the edge is very, very hard, but we'll see how the diamond copes with it. Right, so it took me approximately an hour to establish the bevel edge, and I've probably spent another half an hour to 40 minutes honing that edge down again. So let me just show you, using the standard grits that it comes with, how sharp it is already. Standard piece of paper. Now that is incredibly sharp, and I've still got the fine and extra fine to go. So to change the stones, they can simply just unlock by holding the one end. You can unscrew the ends like so. So I'll take those both off, those to one side. Right, let's start by opening the 3000 grit. Oh, that's lovely. Oh, that's a quick tool change. I like that. And the 6000 grit. Oh, beautiful. And they've actually laser engraved the back to tell you which one it is as well, just in case you misplace it. So to help me to see how much of the blade has actually been ground, I'm just going to use a Sharpie. I mean, you could use engineering blue otherwise. I'm just going to put a line across the edge, and I'm basically looking to make that dark line disappear, and then I'll know that it's been ground sufficiently. It's taken it straight off. That means it's perfectly lining up beautifully. There it is on the stone. Alright, now I use the superfine. Right, so cutting paper is obviously going to be a doddle. No problems. So one of the standard tests I see a lot of chef's knives do is cutting the tomato into the finest layer possible. So this is an almost ripe tomato straight out my polytunnel. If I just cut this in half. So far so good. Now the idea is to lie the tomato face down like that on the chopping board and see how fine a piece you can slice without touching the tomato with your hand. Right, let's just take the top off. Right, now I need to try and get a fine slice without touching the tomato itself. Wow, look at that. Oh, too fine. Right, let's try that again. Wow. That is so thin. Wow, look at that. I mean, that's see-through. Look at that. I think there's technique to this. So what about just dropping it onto the knife? Oh, yes. I've got here a very small Japanese onion. Tell you what, look at how fine that is. Having a good blade makes life so much easier.
So apologies, but I've lost the audio for this bit, but I thought my American friends would at least appreciate how well this blade would cope with 2.5 inch by 1.5 inch studding. A larger, heavier blade would obviously outperform this, but for an endurance test I think this is a good one to do. What I want to see is how well the heat treatment coped with all the stress and strain of trying to chop this piece of wood. More heavier duty clamps would have aided this considerably. So if we go back to the paper test, any nicks will stop this paper from being cut immediately. But as you can see, that retained the edge beautifully. Look at that. Now to seriously test the hardness of that edge, I wanted to try cutting through some steel nails. Something most bladesmiths who have spent a long time making a blade wouldn't dare to try, I would believe. And I think we found its limitations. That didn't stop me having a second go, just to make it a fair test. There we go, it's not miracle material, but let me know in the comments on how well you think it performed. Alright, so I can cook my dinner, I'll have to grind it back again.
I'm going to take my Horl now into the woods and I'm going to sharpen some of my other blades, and I think I'll cook myself a nice tasty meal on the open fire. So I'm going to stop talking now, but if you want to stick around and watch that would be awesome. And if you'd like to see more of this, let me know in the comments and I'll ask Horl if they'd like to sponsor another video. And until our next meeting, why don't you guys get out there and forge yourselves a life worth living. See you soon. be so idyllic if I didn't have a smoke in my eyes.